today we will talk about requirement engineering, and for this slide we will talk about introduction and the foundation of the requirement engineering. First of all, I will talk about the course outline. We have three course outline in this slide. First of all, understand why do requirements engineering, and the second is understand the definition of requirement engineering and some terms, and the last is able to play the role of requirement engineering implementation. Okay, we will talk about the requirement engineering. What is requirement engineering is based on the definition of the IEEE and 110 and 12 in 1990. Requirement is a condition or a capability needed by a user to solve a problem or achieve an objective. A condition or a capability that must be met or posed by a system or system component to satisfy a contract, standard, specification, or other formal imposed document. A document representation by condition or capability as in a system. When we talk about the requirement engineering, we always talk about the stakeholder. Stakeholder of a system is a person or organization that has a direct or indirect influence on the requirement of the system. The term stakeholder is essential in requirement engineering. Among other things, stakeholders are the most important source of requirement. Not considering a stakeholder often result in fragmentally elicit requirement, for example, incomplete requirement. Stakeholders are those people or organizations that have some impact on the requirement. This could be people that are going to interact with the system, for example, user or administration. People that have a more interest in the system but are not likely to use, for example, the management or the admin of the system, which the system must be protect, stakeholder or computing system, but also legal entities, institution, department, or etc. Because they are embodied by living people who may choose the influence or define the requirement of the system. This is the importance of the stakeholder. And the next, we will talk about the requirements engineering. Definition of the requirement engineering is a systematic and disciplined approach to specification and management of requirement with the following goals. There are two following goals: knowing the relevant requirement, achieving a consensus among the stakeholders about the requirement, documenting them according to given a standard, and managing them systematically. And also understanding and documenting the stakeholder desire and needs, and also they specifying and managing requirements to minimize risk of delivering system that does not meet stakeholder what they needs. There are four activities of the requirements engineering. First of all, elicitation. During requirement elicitation, different techniques are used to obtain requirement from stakeholder and other resource and to refine the requirement in greater detail. And the second activity is documentation. During the documentation, the elicited requirements are described adequately. Different techniques are used to document the requirement by using natural language or conceptual model. And the third is validation and negotiation. In order to guarantee that the predefined quality criteria are met, documented requirements must be validated and negotiated early on. This is the importance of the requirement engineering. The 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 engineer make a boundaries of the system. And the last is the management. Requirement management is the orthogonal to all of the activity and comprise and many measure of the necessary to structure requirement to prepare them so they can be used by different roles to maintain constantly after change and to ensure the implementation of the system is same as stakeholder needs. The next is embedding requirement engineering into process model. We will know that there are several of the process model like traditional process model and modern process model. Requirement engineering as a self-contained piece. Ponderous process model, for example, a waterfall model or the V model, I'm at the completely eliciting and documenting all the requirement in early of project. This is important that you need to know that in the ponderous process model or traditional process model like a waterfall and V model, I'm to completely eliciting and documentation all requirement in early of the project phase before any design or realization decision are made. Make this point that it's important to finish all requirement in the first of the phase project. The goal of such model is to elicit all requirement prior to the actual development. As a result, in this process model, requirement engineering is understood to be finite, time restricted initial phase of the system development. This is the benefit of the traditional or ponderous process model, but also they cannot change the requirement. And the next is the lightweight process model, for example, extreme programming. On other hand, only elicit necessary requirement once they are supposed to be implemented as foretelling future functionalities. It's difficult and requirement change over the course of the project. In the process model, requirement engineering is treated as a continuous, comprehensive process that comprises and integrates all phases in the system development. So this is a big difference with the first of the model. In the if the first model, we elicit all the requirement in the first of the phase. But for lightweight process model, for example, extreme programming or agile, we just elicit a necessary requirement as of the supposed implementation of the first phase. This is a big difference. Okay, the next we will talk about the fundamental of the communication theory if you want to be a requirement engineer. First is a language as a medium for requirement communication. Requirements must be communicated in most cases when used as a rule-driven medium that is accessible to the communication partner with a natural language. For the transmission of information from one individual to another to work properly, a common code is needed. The sender encodes her message and the receiver has to decode it. Such as common code intrinsic to any two people that speak the same language. For example, you and me, you as a stakeholder and I as a requirement engineer, we must speak at the same language. This is the example, and have the same cultural background and have a similar experience. The more similar and the cultural educational background and the area of expertise and the everyday work life, maybe it's the better information to exchange. However, such ideal condition most often that not existing between stakeholders. This can, for instance, be achieved by means of glossary. So if you want to uh, make a difference, or we not in a suitable condition, you can make some glossary in which all important terms are explained. And also, this this key is to maintain or to prepare you to get a suitable result. For example, you don't understand about the theory, about the practice, about the anything about this system, so you can make a glossary uh, to explain the key term of each of the phase. Alternatively, this can be done by agreeing upon a formal descriptive language, such as Unified Modeling Language or UML. The second is type of communication medium. Another important factor is the type of communication medium. In verbal communication, the success of the communication relies heavily on redundancy. For example, language gesture or language and intonation, and also the feedback. In written technical communication, for example, information is transmitted with a minimum redundancy and a feedback. And the second is language comfort. In addition to the problems arising for different domain vocabulary and different communication media, it can often be observed that information is not adequately transmitted or not transmitted at all. This can be traced back to a natural transformation that occur during the human perception. These transformational effects are in the particular focusing on simplification and can impact the communication or more or less harshly. The last is implicit background knowing. Communication, for example, is the language-based expression of the knowledge. It's necessarily simplified in the nature. The author expects the reader to have some kind of implicit background knowledge. It is the simplification that arises from language-based knowledge expression that become problematic with a regard to requirement, as a requirement can become interpretable in a different way. And the next, we will talk about the characteristic of the requirements engineering. Maybe you have some of the capability of the requirement engineering. First of all, requirement engineering is a central role of the system. The requirement engineering as a project role is often at the center of attention. He or she is usually the only one who has direct contact with the stakeholder and has both the ability and the responsibility to become as familiar as possible with domain and to understand it as well as possible. He or she is the one that identifies the needs underlying the stakeholder statement and amends them in a way the architect and developers. Usually, laymen where the domain in question is concerned can understand and implement them. The requirement engineering is a manner of speaking, a translator that understands the domain as well as a particular language will know and also process among the information technology and know how to be aware about the problems that the developer face and they're able to communicate with them on the same level. So in this space or in this criteria, if you want to be a requirement engineer, you must able to bridge between a stakeholder and a developer. The requirement engineers, therefore, has a central role in the project. The next, seven necessary capability of requirement engineering. To able to fulfill all of tasks, The requirement engineering needs much more than process knowledge. Many of the capability required must be based on the practical experience. First of all is analytical thinking. The requirement engineering must be able to become familiar with domains that are unknown to her and must understand and analyze complicated problems and relationships. Science stakeholders often discuss problematic requirements by means of concrete example and suboptimal solution. The requirement engineering must be able to abstract from the concrete statement of the stakeholder. The second is empathy. The requirement engineering has the challenge task of identifying the actual needs of the stakeholder of a stakeholder. A core requirement to be able to achieve this is to have good intuition and empathy for people. In addition, he or she must identify problems that might arise in a group of stakeholders and act accordingly. The third is communication skill. To elicit the requirement from stakeholders and interpret them correctly and communicate them in a suitable manner, a requirement engineering must have a good communication skill. He or she must be able to listen, ask the right question at the right time, notice when a statement does not contain the desired information, and make further inquiries when necessary. The fourth is the conflict resolution skills. Different options or different opinion of different stakeholders can be a cause of conflict during requirement engineering. The requirement engineering must identify conflict mediated between the parties involved and apply techniques suitable to resolve the conflict. The fifth is modern skill. Moderation skill is the requirement engineer must be able to mediate between a different opinion and lead discussion. This holds true for individual conversation to help as well as a group conversation and a workshops. And the sixth is a self-confidence. Since the requirement engineer is frequently at the center of attention, he or she occasionally is exposed to criticism as well. As a result, he or she need a high level of self-confidence and the ability to defend herself sound so strong objection to her or his opinion arise. He or she should never take a criticism personally. This is very important. And the last is persuasive. Among the requirement of the stakeholders, she or he must be able to represent the requirement in the team meeting and presentation. In addition, he or she must conciliate differing opinion and facilitate a decision in the case of disagreement and create consensus among the stakeholders. Next, we will talk about the requirement types. There are several requirement types in the requirement engineering. First of all is a functional requirement, quality requirement, and a constraint. Functional requirement define the functionality that the system to be developed offer. Usually these requirements are divided into functional requirement, behavioral requirement, and data requirement. And the second is a quality requirement. Define desired qualities of the system to be developed and often influence the system architecture more than functional requirements do. Typically, quality requirements are about the performance, ability, dependability, scalability, or portability of the system. Requirements of this type are frequently classified as a non-functional requirement. And the last is the constraint. Constraint cannot be influenced by the team members. Requirement of this type can constrain the system itself. For example, the system shall be implemented using web service or the development process. The system shall be available on the market later secondary quarter of the 20 and 22. In constraint, two functionality and quality requirement constraints are not implemented. They are there to because the merely limited solution space available during the development process. So when we talk about the requirement types, there are three types: functional requirement, quality requirements, or non-functional requirement, and the last is the constraint. The last is the importance and categorization of the last is important and categorization of quality requirement. In daily practice, a quality requirement of a system are often not documented, inadequately documented, or improperly negotiated. Such a circumstance can threaten the project success or the subsequent acceptance of the system under development. Therefore, the requirement engineer should place special emphasis on this elicitation, documentation, negotiation, quality requirement during the development process. Typically, many different kinds of desired quality of the system are assigned to the requirement type of quality requirement. In order to be able to deal with a quality requirement in structured manner, many different classification schemes for quality requirement have been proposed. For example, the ISO or IC 27010 and 2010, 2011, and the standard of ISO 25010 in 2011. For example, the suggest classifications came for quality requirements that can also be used as a standard structure for requirement documentation and as a checklist of requirement elicitation and validation. Among others, the following categories are typically for quality requirement. Currently, quality requirements are often specified using a natural language. However, numerous approaches to document quality requirement by means of a model have been suggested over the past couple of years. The requirement engineer is possible for making sure that quality requirements are objective and verifiable as possible. Typically, this necessitates that the quality requirements are quantified. For example, a quality requirement with regard to system performance could specify that a system shall process 95% of all queries within 1.5 seconds, and that it must is not to take a longer than 4 seconds to process query at any given time. This is for example of the quality engineer or the quality requirement. The last is the summary of the slide of this conversation. Requirement engineering can be hardly be avoided, especially when the system are to be developed that satisfy customers and meet budget constraint and schedule. And the second is the goal of the requirement engineer is to document customer requirement as completely as possible in a good quality and to identify and resolve problem in the requirement as early as possible. The third, successful requirement engineer is based on including the right stakeholder as well as embedding the four core activity of requirement engineering: word of elicitation, documentation, validation, negotiation, and management into the system development process. And the last is at the center of the attention is the requirement engineering, who is the primary contact point in the requirements engineering and poses as a great deal of the domain knowledge and process knowledge as well as a multitude of a soft skill. That's all for this presentation. Thank you very much for your attention.